Let us see the syllabus of the unit number 5, rotational motion. The first topic is about the center of the mass of a two-particle system, then the center of mass of rigid body. Then is the basic concept of rotational motion, the moment of a force, torque, angular momentum, conservation of angular momentum and its applications. The next is about the moment of inertia, radius of gyration. Then is the values of moment of inertia for simple geometric objects. Then is the parallel and perpendicular axis theorem and its applications. Then is the equilibrium of rigid body rotation and equations of rotational motion. And finally is the comparison of linear and the rotational motions. We are taking the basic concepts, important terms and formulae of the topic rotational motion. Among that, the first one is about the center of mass. Consider a system consisting of two particles of masses m1 and m2 at points A and B. These are the points A and this point is B. The point where position vector r, this is the point where the position vector capital R is given by the relation, is known as center of mass of the system, and this r is given by the product of mass m1 and its position vector r1 plus m2 r2 divided by m1 plus m2. The next is about if the center of mass of a system of a particle, then if suppose n number of particles are there, then position vector is generalized up to m1 r1 plus m2 r2 so on up to mn rn divided by m1 plus m2 plus up to mn. Now if we want to find out the velocity of the center of mass of the system, then we have to take the time differentiate of this value r where the center of mass of that system is lying. Now, the fourth point is about the force that is acting on the center of mass of the system. This is given by F is equal to m dv by dt. This is again mass into acceleration, and the time derivative of velocity will give us the acceleration. The next point is very important. The total momentum of the system is same as the momentum of the center of mass. Since whole of the mass is concentrated at the center, so total momentum of the system will be equal to the momentum of the center of mass. No external force, if it is not acting on the system, then the total momentum of the system is going to remain constant. Based on this, many conceptual problem used to come. If no external force acts on the system, then its center of mass moves uniformly in the straight line. And these are the equations of the rotational kinematics. Omega is equal to omega naught plus alpha t. This is just similar as to v is equal to u plus at. In terms of rotational motion, omega is the angular velocity after time t, and omega naught is the initial velocity, angular velocity, and alpha is the angular acceleration, and t is the time taken. The equation number second is theta equal to omega naught t plus half alpha t square. This is just similar to s is equal to ut plus half at square. Then the next equation is omega square minus omega naught square is equal to 2 alpha theta. Again, it is similar to v square minus u square is equal to 2as. So these are in the terms of the rotational kinematics. Here are the few important concepts about the center of mass. The position of center of mass depends on the shape of the body and its mass distribution. These are the two important things that will decide the center of mass. One is how is the shape of the body, and second कि जो mass की distribution है वो कैसी है. Hence it may be within us, inside or outside the material. जो सेंटर ऑफ मास है वो हमारा जो बॉडी है उसके अंदर भी लाई कर सकता है और बॉडी के बाहर भी. जैसे कि अगर हम एग्जांपल लेते हैं डिस्क का, तो डिस्क का सेंटर ऑफ मास विद इन द मटेरियल ऑफ दैट बॉडी लाई करता है. लेकिन अगर हम उसी जगह पे सर्कुलर रिंग की बात करते हैं, तो सर्कुलर रिंग का सेंटर ऑफ मास उस मटेरियल पे ना लाई करके उसके आउटसाइड ऑफ द मटेरियल लाई करता है. तो ये चीज हम लोगों ने यहाँ पे पॉइंट्स में दी है. फॉर एग्जाम्पल सर्कुलर डिस्क, द सेंटर ऑफ मास इज विद इन द मटेरियल, बट फॉर ए सर्कुलर रिंग द सेंटर ऑफ मास इज आउटसाइड द मटेरियल. नेक्स्ट पॉइंट जो है हमारा, ये सेंटर ऑफ मास और ज्योमेट्रिकल सेंटर कोइंसाइड करेगा या नहीं, इस चीज को एक्सप्लेन करता है. अगर हमारे पास सिमेट्रिकल बॉडी है और वहां पे मास डिस्ट्रीब्यूशन जो है वो होमोजीनियस है, तो उस केस में हमारा सेंटर ऑफ मास ज्योमेट्रिकल सेंटर के साथ कोइंसाइड करता है, अदरवाइज वो नहीं करेगा. इन सिमेट्रिकल बॉडीज वेयर द mass distribution is homogeneous, the center of mass coincides with the center of the symmetry of geometric center. If origin is located at the center of mass, that is r is 0 in that case, the position vector itself is lying at the center, and this is for the whole of the system, the center of mass is lying, then the summation mi, this mi is the product of the individual masses and the distance from the origin, telling about the position vectors. Because this thing is 0, so this product will also be 0. This is called as the sum of moments of the masses of the system about the center of mass MIRI, and this will also be 0. The center of mass changes its position only under the translatory motion. A body can undergo both translatory as well as a rotatory motion. For example, if a bicycle is moving, the wheel is undergoing translatory as well as the rotatory motion. And it has been mentioned जो center of mass है वो हमारे पास उसकी पोजीशन सिर्फ ट्रांसलेटरी मोशन में चेंज होती है, बट रिमेन्स अनचेंज इन द रोटेटरी मोशन. रोटेटरी मोशन में हमारा सेंटर ऑफ मास की पोजीशन चेंज नहीं होती. This is a very important thing about the concept of center of mass. It proves that the law of mechanics, as it is true for a point mass, are also valid for the macroscopic bodies. For example, the Newton's laws of motion, which hold good for a point mass, are also valid for large objects like planets and all. Because of this, objects can be treated as point mass by the definition of the center of mass. Center of mass consider the body to be a point mass, and because of that, this laws of mechanics can be taken for the macroscopic bodies also. The next is about the angular momentum of a particle about an axis is given by the cross product of the position vector and the linear momentum. Angular momentum is also called the moment of momentum. Next is about the torque or moment of force. This is the cross product of position vector and the force applied. The next point is, if no external torque acts on the system, then the total angular momentum of a system. So here total angular momentum means the linear momentum as well as the angular momentum of a system always remains conserved. The law of conservation of angular momentum is behind the elliptical orbit plane of a planet moving around the sun remains the same. This constant magnitude of angular momentum leads to the Kepler's second law, according to which the constant direction of angular momentum vector leads to the fixed plane for the orbit of a planet. Next is about the moment of inertia. Its physical meaning it is a property of a body by virtue of which it opposes the torque tending to change its state of rest or uniform rotation about a given axis. This is also called rotational inertia of a body. After the physical significance of moment of inertia, let us see its mathematical formula. It is the sum of product of masses of its constrained particles and square of their respective distance from the axis of rotation, and this is given by the this relation. I is the moment of inertia. It is equal to summation I is equal to 1 to n for n number of particles, and it's a product of the mass and the square of distance from the axis of rotation. Next is about the radius of gyration. It is root mean square distance of particle from the axis of rotation. It is denoted by capital K. It is equal to r1 square plus r2 square plus up to rn square divided by n under the root. It is not a constant quantity. As the location of the axis of rotation changes, the value changes. The next we are talking about the theorems on the moment of inertia. Among that, the first one is the theorem of perpendicular axis. According to this, if there are three mutually perpendicular axes x, y and z, they are meeting at the same common point, say point O, then the sum of moment of inertia of a plane lamina about two axes lying in its plane. Here x and y, they are making a plane lamina, and this is equal to the moment of inertia about the third mutually perpendicular axis is along z axis, is given by Iz is equal to Ix plus Iy, that is making a plane lamina. So this is the statement, and this is the conclusion of the theorem of the perpendicular axis. The next is about the theorem of parallel axis. According to this theorem, the moment of inertia of a body about any axis is equal to the moment of inertia about the parallel axis through the center of mass plus the product of mass of the body and the square of perpendicular distance between the axes. Say at point O, there is lying the moment of inertia denoted by I. Now from the center, IC is the moment of inertia. Then according to this theorem, this moment of inertia is equal to the moment of inertia passing through the center of this plus the product of mass and this perpendicular distance. A is the perpendicular distance between the point and the center. So it is equal to the IC plus m mass into the product of the perpendicular distance between these two points. Here at the end of the topic, I have summed up some center of masses of important rigid bodies. So you can go through these. Here the body is a uniform rod. The position of the center of mass will lie at the midpoint of the rod. For a circular ring, the center of the ring where the position of the center of mass will be there. Circular disc, center of the disc. If we are talking about a plane lamina having a shape of a square, triangle or parallelogram, either of these things are there, their center of mass will lie at the point of intersection of the diagonals. The next is the triangular lamina. Its center of mass will lie at the point of intersection of medians of triangle. If you are talking about the solid bodies, rectangular or cubical block, the point of intersection of diagonals is where the center of mass will lie. If we are talking about sphere, then center of mass will lie at the center. About a cylinder, midpoint of the axis of cylinder. If we are talking about cone or pyramid, its center of mass will lie on the point on the line joining the apex and the center of the base at a distance 1/4 of the length of the line from the base. Here I have summed up the moment of inertia of few rigid bodies. These are the important bodies, generally question is being asked from them. So first is the thin rod of length L, and the axis of it is passing through the center and perpendicular to the rod. So this is the figure, this is the length L and the axis is perpendicular to the length L. Then the center moment of inertia of this is given by I is equal to m L square upon 12. If you're talking about a rectangular plane and the axis is passing through the center and perpendicular to its plane. So this is the figure for this rectangular plane, and this is the axis I, that is the axis of the rotation, and I is the moment of inertia. It is given by m L square plus b square by 12. Next is about the circular ring, and if the axis is across its diameter, this is how the axis is through the diameter, and I is the moment of inertia. It is given by half mr square. Next point is about the circular ring that is having radius r, and the axis is passing through the center and perpendicular to its plane. So in this case, this is the circular ring. R is the radius and I is the moment of inertia, and this is given by mr square. Next is about the circular disk of radius r, and here the axis is passing through the center and perpendicular to its plane. So this is the figure for the same, and the moment of inertia is given by half mr square in the case of circular disk. The next is about the right circular solid cylinder of radius r and length l, and the axis is the symmetric axis that we are taking. So this is a right circular solid cylinder, and this is the axis of rotation. R is the radius of this cylinder and L is the length. So the moment of inertia is given by half mr square. Next is about the body is the solid sphere of radius r, and the axis is across its diameter, and this is the axis of rotation, and its moment of inertia is given by 2 by 5 of mr square. The topic of first is the rigid body, center of mass and its motion, and based on this topic the question that has come is two bodies of mass 10 kg and 20 kg respectively are connected to the two ends of a rigid rod of length 10 meter with negligible mass. The distance of center of mass of the system from 10 kg mass is, and these four options have been given. This question has come in the exam NEET 2022, and this is on the page number 97 of new NCRT. So according to the question, the figure can be drawn for the same. Here there are the two bodies of the masses 10 kg and the 20 kg. Let it be the x-axis and the y-axis. This is the position of mass m1, that is 10 kg. And along y and x-axis, this is the origin at O, and the position is 0. And the other one is 20 kg. M2 is 20 kg at a distance 10 meter from here. So this is at the 10 0. The next is about the find out the distance of center of mass of the system from 10 kg. From here we have to find out, let C is the position of the center of mass. So to find it out, let X is the position of the center of mass at point C. This is given by, according to the formula, if you remember, m1 r1 plus m2 r2 by m1 plus m2. This is the formula for the center of mass. So from here we have the mass 10 into its position vector is 0, m2 20 and position is 10, m1 plus m2 10 plus 20. So the value comes out 20 by 3. This is in meter. So if we look at the options, our option A goes with the solution, and the answer for the first is A option, 20 by 3 meter. Now the second question, it is about three identical spheres, each of mass m, are placed at the corners of a right angle triangle with a mutually perpendicular sides equal to 2 meter. Taking the point of intersection of two mutually perpendicular sides as the origin, find the position of the center of mass. And this is the figure that have been given. Here the masses are placed at the corners of a right angled triangle with the mutually perpendicular sides equal to 2 meter, taking the point of intersection of two mutually perpendicular sides as the origin. So here we are taking as the at this point as the origin. Find the position of the center of mass, and options have been given. This question has come in the NEET October 2020, and this is on the page number 97 of new NCERT. To solve this question, we have to see that here the directions also have been mentioned, I and J. So we'll apply the formula for the center of mass. Let this position is denoted by X. There are the three bodies of mass m each, and one of them is lying at the origin. So we have m. Now these directions have been mentioned and the options are also given in the form of these directions, so we will consider them too. So in this case I am taking the first, that is lying at the origin, and the distance is 0 for it. The next is this m. This is lying at 2 units in the I cap direction. So this is denoted by 2i. And this is for this mass m. This is 2 units in the j direction. So 2j for that. And that is divided by m plus m plus m. Now we will have m to I cap plus j cap by 3m. M cancels out here. So we are having 2 by 3 I plus j. Now if we look at the options, our answer goes with the option number C, and the answer for the second is C option, 2 by 3 of I cap plus j cap. This is the question number 3. Two particles of mass 5 kg and 10 kg respectively are attached to the two ends of a rigid rod of length 1 meter with a negligible mass. The center of mass of the system from the 5 kg particle is nearly at a distance of, and these four options have been given. This question has come in the NEET September 2020, and it is on the page number 97 of new NCERT. So let us draw the figure for it to find out the center of mass from the 5 kg particle. So these are the two masses, 5 kg and 10 kg. These are attached to the two ends of a rigid rod of length 1 meter with a negligible mass. The center of the mass of the system from 5 kg particle is, let O be the point of the center of mass lying at the origin. Let O is the center of mass position at origin. Let this distance is R1 and this is R2. And we are supposed to find out the value of R1 because this R1 is the distance between the 5 kg and the center of mass, and this is what we have to find out. So applying the formula M1 R1 plus M2 R2 over M1 plus M2. This is for the origin of the center of mass. Now this is lying at the origin, so this value is 0, and M1 R1. Since this is lying at the left side of this origin, so it is with the minus sign, plus M2 10 R2 divided by 5 plus 10. So we have minus 5 R1 plus 10 R2 is equal to 0, or from here we have minus 5 R1 is equal to minus 10 R2 or we get R1 is equal to twice of R2. This is one of the equation. Now, in the second equation, one more we have R1 plus R2 is equal to 1 meter. Since the options have been given in centimeter, we can take it R1 plus R2 equal to 100 centimeter. And from here we have R1 is equal to 100 minus R2. Now we can put the value of R2 from equation number 1 into equation number 2. So we have R1 is equal to 100 minus R1 by 2. So this value will come out twice of R1, 200 minus R1, or 3R1 is equal to 200. From here R1 is equal to 200 by 3. So this value is nearly equal to 67 centimeter. So if we look at the options, our result goes with the option number B, and the answer for the third is option B, 67 centimeter. So at the center of the mass from the 5 kg particle is at a distance 67 centimeter. Now the question number 4, which of the statement are correct? And these statements have been mentioned, and these are the options. 2 of these statements are correct because in the options we are having 2 statements. This question has come in the NEET 2017 and it is on the page number 97 of the NCERT new. So let us see the statements one by one. First is A, center of mass of a body always coincides with the center of gravity. So if you remember the concepts there we have done, the center of mass of a body only coincides with the center of gravity if it is a symmetric geometrical figure and mass distribution is homogeneous. The mass distribution needs to be homogeneous. This is not always true. So this statement is not correct as a whole. The next one is the center of mass of a body is the point at which total gravitational torque on a body is 0. So if we talk about the center of mass, there the torque, it is the cross product of the position vector and the force applied on it. Let Ri is for the I number of the particles and summation is going to give us the total torque. Now this Ri will be 0 at the center of mass, and that is why the value will come out to be 0. So this statement is correct. The center of mass of a body is a point at which the total gravitational torque on the body is 0. Next is a couple on a body produces both translational and rotational motion in a body. So it is not so. Couple is having turning effect, rotating effect. So it is not concerned with the translational motion. It is only concerned with the rotational motion in a body. So again, this statement is not correct. The next is the mechanical advantage greater than 1 means that small effort can be used to lift a large load. To see this, first we will see the mechanical effect. This mechanical advantage is equal to load over effort. If this mechanical advantage, it is greater than 1, if this is greater than 1, it means load is greater than effect. Now let us see the D statement. Mechanical advantage greater than 1 means the small effort can be used to lift a large load. So first we will see what mechanical effect is equal to. Mechanical advantage is the ratio of load over effort. If this value is greater than 1, it means load is greater than effect, or we can say small effect is going to lift a large load. So the statement D is again true. So if we take the combination of true statement, it is B and D, and it is with the option number D. Hence, the answer for the fourth question is our option number D. Both B and D are the correct statement. Now let us see the question number 5. Two persons of masses 55 kg and 65 kg respectively are at the opposite ends of a boat. The length of the boat is 3 meter and weighs 100 kg. The man 55 kg walks up to the 65 kg man and sits with him. If the boat is in still water, the center of mass of the system shifts by. And these four options have been given. This question has come in All India PMT 2012, and this is on the page number 97 of the NCERT New. So if you again look at the statement of the question, this is a purely concept based question. And if you remember the concept, in whole of this statement, there is no application of the external force. Here, the answer number fifth, in this system, there is no external force applied. Again, see the statement. There are the two masses. These masses are of the two persons. They are sitting at the opposite end of the boat. Length have been given. Weight of the boat have been mentioned. And one of that 55 kg man is moving towards the 65 kg man. And we have to find out how the center of mass have been shifted. So again, going through the statement, it is confirmed that in the system there is no external force applied. External force, if it is applied, is zero. There is no change in the center of mass. Then center of mass has no shift. So our option number C goes with our concept that there is shift by zero. So answer for the fifth is C. Now we are taking the topic number 2, torque and equilibrium of rigid body. In that, the first question is, a uniform rod of length 200 centimeter and mass 500 gram is balanced on a wedge placed at 40 centimeter mark. A mass of 2 kg is suspended from the rod at 20 centimeter and another unknown mass m is suspended from the rod at 160 centimeter mark as shown in the figure. So this is the figure that have been provided, and whatever is there in the statement is depicted in this figure. The 2 kg mass is being hanged at the marking 40 centimeter. This is a wedge at 40 centimeter and this is the mass at marking 160 centimeter. Along with that, this is have been given. This rod is of length 200 centimeter. So this is 200 centimeter rod is there. Now another thing is this, the mass of 2 kg is suspended from the rod and the other is unknown. Along with that, the uniform rod of length and mass 500 gram. The rod is having the mass 500 gram. Now find the value of m such that rod is in equilibrium and g is to be taken 10 meter per second square, and these are the options being given, and this question has come in the NEET 2021. It is on the page number 109 of new NCERT. So whatever the things have been given is being taken in the figure. Along with one more thing is there, that mass is 500 gram and it is balanced on a wedge placed at 40 centimeter. So the center of mass, since it is a uniform rod, will be lying exactly at the center of the rod. Let us take this as the center of rod. So 500 gram will be hanging from here. So mass into acceleration due to gravity mg. This force will be lying from this point. And this is exactly at the midpoint. So this is 100 centimeter and this is also 100 centimeter. Now we are supposed to find out this mass m. And one more thing is being given, the rod is in equilibrium. For equilibrium, the torque that is acting at the one end of the rod, since it is balanced at this wedge, so the torque acting within this will be equal to the torque acting within this part. These two torques will be equal. We'll equate these and then find out the value of m. So if we look at this position, this is at the, this 2 kg mass is at the value 20 centimeter. So torque on left side is 2 into g. This will make a force into 20. Now the torque on right side. On right side, two masses are hanging. One is 500 gram and another is m. So if we look at 500 gram, what is the position of this? Since this total is 100, from this point to this point it is 100 and this point is at 40. So this point is 100 minus 40, that is 60 centimeter. So 500 gram is being hanging at 60 centimeter. We will convert in kg, that is 0.5 into 60 plus. Now this mass, this is lying at 160 centimeter and its distance from this point will be given by total is 160. Out of that we will subtract this 40. So this distance will be 160 minus 40 centimeter, that is 120 centimeter. So M is hanging at 120 centimeter. Now equating these two torques on the both hand side, we have 2g into 20 is equal to 0.5 g into 60 plus mg into 120. So g is being cancelled out throughout. 0.5 into 60 plus m into 120. 40 is equal to 30 plus mass is 120, and from here we get 10 120 m, or m is equal to 10 upon 120. So mass comes out 1 by 12 kg. If we look at the options, our answer goes with option number D, and the answer for the first is option D, 1 upon 12 kg. Now the second question is, find the torque about the origin when a force of 3j cap Newton acts on a particle whose position vector is at 2 k cap meter. These are the four options being given, and this question has come in the NEET September 2020. It is on the page number 105 of new NCERT. So this is simply formula based question. Since torque is r cross f, so the position vector r is being given at 2k meter and the force is 3j cap. So putting these values, we get torque equal to 2 k cap cross 3 j cap. K cross j will be minus I, and 2 3s are 6, so it is minus 6 I cap Newton meter, and our option number B goes with the solution, and the answer for the second is option B, minus 6 I cap Newton meter. Third question is find the moment of the force, and the force have been given here at coordinates have been given about the point is given by. So these are the options given. This question has come in NEET 2018 and it is on page number 105 of new NCRT. This is again a formula based question. To find the moment of force, we have the formula. It's a cross product of position vector into the force. Now to find out this value of R, we know according to the values given, using these coordinates, we have R1 is given by 2i minus 2j minus 2k cap, and R2 is being given here 2i cap plus 0j cap minus 3k cap. The value of R is given by R2 minus R1, and this value is this value comes out 2i minus 2i cap plus 0j cap plus 2j cap minus 3k cap plus 2k cap, or R vector comes out 0 plus 2j minus k cap. The moment of force is given by the cross product of 2j minus k. This is the moment of force that we are calculating. Cross F is being given 4i cap plus 5j cap minus 6k cap. To find this value, we'll put it in the form of ijk 0 2 minus 1 4 5 minus 6. This is given by I cap minus 12 plus 5 minus j 0 plus 4 plus k cap 0 minus 8. So this value comes out minus 7i. This is minus 4j and this is minus 8k cap. So this is the value of the moment of force we calculated. And if we look at the options, the option number D goes with our solution. So answer for the third is option number D, minus 7i minus 4j minus 8k cap. This is the question number 4. A couple produces no motion, linear or rotational motion, purely rotational motion, purely linear motion. This question has come in All India PMT 1997 and it is on page number 110 of new NCRT. This is purely concept based question on the couple. Couple is a pair of equal and opposite force, equal in magnitude and opposite in direction. So when this type of force is being acting, the net force is 0. Since net force is 0, therefore there will not be any translatory motion. Translatory motion will not be there. But this pair of equal and opposite forces, they produce, couple produces rotatory motion. it basically gives the turn. A equal and opposite force produces a rotatory motion. So from these concepts we conclude that a couple produces no motion. No, there is a rotatory motion. Linear and rotational motion, linear translatory is not there. Purely rotational motion, purely linear motion. Purely linear motion is not there. Linear is not there. So this option is not correct. No motion, motion is there, rotatory. So option number C goes with our concept, and answer for the fourth is C option, purely rotational motion when a couple is being produced or is being applied.